Hello everyone, and welcome to this presentation on automating Windows 7 deployment. My name is Greg Tate, and I'm the desktop engineer for Catapult Systems. My main role with the company centers around IT support, and over the past 2 years I've been deploying Windows Vista, Server 2008, and Windows 7 beta and release candidate versions to our end users. So today I'd like to share with you a few ideas on how to get a head start on your Windows 7 deployment. This presentation is geared towards IT professionals who have a role in the management and distribution of operating systems. My intention is not really to go too deep into the aspects of Windows 7 deployment. Instead, I want to bring to the surface a few topics you should consider when moving to Windows 7. So if you have any questions, please submit them to the Q&A part of the live meeting, and I'll be able to answer them at the end of this presentation. So some of these topics include a brief overview of Windows 7 deployment, including the steps you need to take to prepare for Windows 7 deployment, along with the new technique in imaging that you couldn't quite accomplish in Windows XP. I'll also talk in good detail about Microsoft's new BitLocker drive encryption system and how you can prepare for and integrate it into your deployment scheme. I'll mention a few things about the importance of the Windows recovery environment and how you can deploy it in your organization. I'll talk about user state migration, its new features, and how this particular version of the tool revolutionizes the migration process. And the last topics I'll cover will focus around how you can deploy the Windows Arrow interface, along with a few other tips and tricks. In the end, I'll throw in something really cool that will be followed by a question and answer session. So stick with me and enjoy this presentation. Before you do any kind of deployment in your environment, you should check for the compatibility of your business-critical applications. Windows 7 brings a lot of new features that may render XP applications incompatible. So you should make sure that your important applications can run on Windows 7 and Internet Explorer 8. If they can't, then you should either look to a vendor-supported upgrade or use the Application Compatibility Toolkit. With the Application Compatibility Toolkit, you can grab an inventory of which applications are used on your network and determine whether that application is compatible with Windows 7. If it isn't compatible, then you can use the Application Compatibility Toolkit to shim the application and force it to work under Windows 7. If the computers in your organization are several years old, then you'll need to make sure that these machines can run Windows 7. In our experience so far, we have found that you really need to pay attention to the RAM and the video controller. Windows 7 will use significantly more RAM than Windows XP. So as a safe measure, all of your computers should have at least 2 gigabytes and preferably 4 gigabytes of RAM. Windows 7 also needs a sufficient graphics card for displaying the Arrow interface. This is especially the case for computers with dual screens. So to ensure proper display performance for a dual screen system, you should use a video card that has at least 256 megabytes of memory. You can also use a tool called the Microsoft Assessment and Planning Toolkit to collect hardware information about the computers in your environment. The MAP tool provides this information to you in a detailed report and suggests actions to take for each system should they not meet the hardware requirements for Windows 7. So as your deployment plans unfold, you'll need to make a decision on which deployment system you would like to use for moving your organization to Windows 7. If you have just a handful of computers in your environment, then you may want to do a Windows 7 upgrade. An upgrade will carry over all existing files, applications, and user accounts, and it really is the least intrusive method of deployment. The drawback is that it has a number of limitations. For one, IT departments generally do not prefer upgrades because upgrades have a tendency to break applications. And because of this, Microsoft specifically chose not to provide an upgrade path from Windows XP to Windows 7. You also cannot perform an upgrade from a 32-bit operating system to a 64-bit operating system. So when an upgrade is out of the question, the next route you should consider is something called a clean install. A clean install is something new with Windows Vista and Windows 7. And unlike an upgrade, where you would launch setup.exe while running in your existing operating system, for a clean install, you need to boot to the Windows 7 media. And what a clean install does is move all of your existing directories, including C documents and settings, C program files, and C Windows, into a new directory at the root of the hard drive called C Windows.old. This allows you to keep every bit of data that's on your machine. However, the drawback is that you lose your applications, and you have to drag and drop files. You have to drag and drop your files from the windows.old directory and into your new Windows 7 folder. So at this point, what I want to do is provide a quick demo to show you how this operation works. So right here, we're looking at a virtual machine. This is in Hyper-V, and I previously installed a version of Windows XP on there, and I boot to Windows Deployment Services. So we're going to look at the root of this hard drive, and right here, just by looking at this file structure, you can tell that it's a Windows XP operating system simply by the existence of the Documents and Settings directory. So I'll exit out of here, and I'll choose to apply this Windows 7 image to this hard disk. I'll receive a message stating that all of your Windows files will be moved to Windows.old, and I'll accept this change, and here the installation process takes place. And let's look at the command at the structure right now. We still have our existing Documents and Settings, but during the imaging process, you'll see that Windows creates this Windows.old directory. So let's go into that directory. And here, you'll notice that all of the files that were at the root of the hard drive are now contained in this Windows.old directory. The great part about this is that this process, this new clean install process, is non-destructive. So you don't have to worry about losing any data when you deploy Windows 7 in your environment. Okay, so back to the presentation. You can do a clean upgrade, or that's an upgrade or a clean install, by posting the Windows Media 7 files to a network share, but this method is not recommended if you require more automation, such as joining your computer to the domain. For this, you'll want to use a dedicated Microsoft deployment service, and there are three main ones. The first one I'll talk about is Windows Deployment Services. WDS was introduced in Server 2003 R2 and is a role in Server 2008 and Server 2008 R2. WDS is great for small organizations who need to image computers on request. You can automate all aspects of a Windows 7 migration and deployment scenario with WDS, but the main drawback to WDS is that automation typically requires an intimate knowledge of the Windows 7 deployment tools. So if you have a larger environment, or if you just need to get started right away with Windows 7 deployment, then you should look into another tool called the Microsoft Deployment Toolkit. The Microsoft Deployment Toolkit uses all the tools you have to learn for automating deployment with WDS, except that everything is built in for you. This will help to cut your learning curve, as it can take months to understand how to use the deployment tools without Microsoft Deployment Toolkit. Microsoft Deployment Toolkit also provides better features for management and security. For instance, MDT allows you to replicate images across your network. It allows you to organize and manage drivers, operating systems, and applications. And you can also automate user interface functionality with PowerShell. MDT has two well-known features called Light Touch and Zero Touch. With Light Touch, users can choose to customize their own image, and with Zero Touch, administrators can use System Center Configuration Manager to push an operating system down to a client without any need for user interaction. The link at the bottom refers to a great walkthrough configuring the MDT tool and performing your first automated installation. And I really recommend it if you want to get started with Windows 7 deployment. So the solutions I've mentioned beforehand are best for smaller organizations. But if you're shooting for mass deployment, then you'll want to use a product called System Center Configuration Manager. This product is formerly known as SMS and has been around since 1994. The official word from Microsoft is that Service Pack 2 for Configuration Manager will introduce operating system deployment support for Windows 7 and Server 2008 R2, and the release date for this service pack is somewhere between October and November of this year. So if you haven't deployed Windows Vista or Windows 7 before, then you have a bit of catch-up work to do. This is because Microsoft significantly changed the deployment process from Windows XP. For one, Windows no longer decompresses a set of files during installation. Instead, Windows deploys just one file, which is called a Windows image file, or a .wim. The reason for this change is that by deploying one image file, you get a significant reduction in installation time due to the lack of overhead involved with opening and closing many individual compressed files. You can also do many other things with WIM files, but I'll get to that later. The main thing to note here is that you'll be working with image files from here on. The next thing to understand is that automating Windows setup is way more complicated in Windows 7. In Windows XP, you can launch the Setup Manager application and use it to generate a nicely crafted answer file, which is easily edited in Notepad. Well, in Windows 7, that answer file format has changed to an XML-based file format, and now relies on catalog information from a .wim file that sits on the Windows 7 media. So what all this means is that you just can't open Notepad and start crafting your answer file. Well, take that back. You could, but it's just not friendly to look at. Instead, in Windows 7, you use an application called Windows System Image Manager, and this tool is bundled in a package called the Windows Automated Installation Kit, or WAKE for short. WAKE is a free download from Microsoft Deployment, and it is imperative for use with Windows 7 deployment. Among other aspects that have changed with regard to deployment is how the Windows boot process behaves. This is important to understand because with BitLocker and VHD booting, administrators will need to manage situations where the boot files are no longer stored on the operating system volume. In Windows 7, you will encounter situations where you need to have an understanding of this new boot behavior. So as a quick overview, Windows XP, the hard disk format process for it, creates a boot record at the beginning of the disk that calls the NT loader application. The NT loader application retrieves settings from the boot.ini file and uses these settings to load Windows. In Windows 7, you no longer have these files. Instead, the Windows 7 disk format process puts a boot record that points to an application called Boot Manager. And Boot Manager retrieves the settings from the boot configuration data store. And instead of using Notepad to edit the boot.ini file, you use a command line tool called bcdedit to make changes to their BCD store. You'll need to use bcdedit tool for advanced deployments of Windows 7 of VHD booting and the Windows recovery environment. And you'll want to gain an understanding of it before you deploy BitLocker. So I've already mentioned the Windows Automated Installation Kit, but let me reiterate that this tool is vital for automating Windows 7 deployments. With WAKE, you get the super helpful command line imaging tool called ImageX, and ImageX is a file-based capturing and deploying utility. This means that the image file sizes are much smaller than sector-based image files. And when you deploy a file-based image to a clean hard drive, the image comes defragmented by default. This gives you better disk performance after operating system installation. With WAKE, you can mount an image file to a directory and make changes to it. You can even install drivers and updates. This means that with image deployment in Windows 7, you no longer have to concern yourself with keeping images for different computer types. You can now have one image that works on all of your workstation and laptop hardware and can be easily kept up to date. Another product that comes with WAKE is something called WinPE. WinPE stands for the Windows Pre-Installation Environment and is basically a bootable version of Windows 7 with just a command line interface. Its usefulness comes in how you can run all of your deployment with it. For instance, you can format disks, modify partitions, attach to network shares, capture an image, deploy an image, and even do a network backup with the user state migration tool. WinPE is used throughout all portions of the Windows 7 deployment, and in fact, when you boot to the Windows 7 media, you are booting to a WinPE environment. These tools have all been around since the first version of WAKE back in Vista RTM. So let's look at some of the new features that WAKE for Windows 7 brings. So in terms of deploying, in terms of changes in deployment between Windows Vista and Windows 7, there really aren't that many differences. There are a few changes in the WAKE. There's a new command line tool called DISM, and that stands for Deployment Image Servicing and Management Tool. With the DISM tool, you can do the same functions as ImageX, but you can also incorporate drivers, add operating system features, apply unattend file settings, and change product keys. And Windows 7 creates the setup process. If you deploy Windows 7 to a clean hard drive, it will create 2 partitions by default. And this is in preparation for BitLocker. So this is the first operating system that actually puts 2 partitions on a hard drive by default. Another new feature in the Wake kit for Windows 7 is called VHD booting. You can manage VHD files and create VHD files straight from the disk management console in Windows 7. And you can use a few command line tools to install an operating system such as Windows 7 or Server 2008 R2 to this VHD file and incorporate it into your boot manager so that you can now boot to a VHD. The drawback to VHD booting is that it's really not supported for older operating systems such as Windows Vista or Windows XP. And really one of my favorite features of the new Wake is this concept called hard link migration. And I'll get to this later at the end of the presentation. But just know that migration times in Windows Vista would take 30 minutes to an hour and a half or more, whereas a hard link migration in Windows 7, this new hard link feature, can reduce migration times to 15 minutes or less. Now, migration times mean here not the whole imaging deployment, but just the transfer of your files and settings. Okay, so with Wake, you can build your images in a virtual machine and configure them to configure the image that you capture from this virtual machine. You can configure the image offline to be compatible with all of your hardware. So let's take a look at how all this process is done. The first step I normally take is to build a Hyper-V machine and install my operating system in it. You can supply a new setting in the answer file that will copy the default profile, copy the administrator profile to the default profile. And once you have your machine configured, you can take a snapshot first and then sysprep your machine. And by taking a snapshot first, it'll allow you to easily revert back to the pre-sysprep state, and this will allow you to keep your image configuration. So once you sysprep your image, you can boot to a WinPE environment and capture it with ImageX using the command line tools. And all of this process is really documented in the Wake documentation in the TechNet library. Once you've captured your image into a WIM file, you can use the new DISM tool to incorporate your image, your drivers into the image. So let's say you have a whole hierarchy of folders, each with their own driver. You can actually call this command to recurse through all of those folders and install every single driver. So after that, you can then edit your answer file to bundle in some additional features. Now, some tools such as the Microsoft Deployment Toolkit and System Center Configuration Manager can do this for you automatically. But the way we deploy images at Catapult is with Windows Deployment Services. And so WDS really doesn't offer anything on the surface to do this. So you can script all of this in batch files, and that's essentially what I've done for our imaging process. And I'll show you this later in the presentation. So once you've done injecting your drivers, you can commit your image with ImageX and import it into your image system. And if you have several branch offices, you can use the distributed file system replication service to dish out the images to other DFS servers in other offices. Okay, so one of the growing problems in IT today is the prevention of data theft. This is especially the case for IT departments who have a lot of mobile users. If a laptop gets stolen, it would take a matter of minutes before someone to look at the contents of a hard drive and retrieve any data from it, regardless of what passwords are used on the system. So to combat this, Microsoft introduced a feature in Windows Vista called BitLocker Drive Encryption. BitLocker is a logical drive encryption system that protects data in such a way that a malicious person cannot access any data on a BitLocker protected volume without first having to provide pre-boot authentication. This pre-boot authentication can take place transparently, relying on a key stored in the motherboard's trusted platform module, or you can have the user perform authentication manually in conjunction with the TPM, such as providing a PIN or a USB startup key. And I mentioned earlier that BitLocker drive encryption is a logical disk encryption system. This means that BitLocker works on volumes, not partitions. So to clarify the difference, a physical hard drive can have several partitions, and each partition may have one or more logical volumes. This bit of knowledge comes into play because BitLocker requires two volumes, one for the boot files and another for the encrypted operating system. If you take a look at the way Windows XP and Windows Vista format the hard disk by default, you'll find that the setup process creates one partition that contains one volume for the operating system. And so since BitLocker requires two volumes, you'll need to figure out how you can get a second volume on this disk. One option is to do what's called a Windows 7 wipe and load. Okay? A Windows 7 wipe and load is basically what happens is you delete the hard disk of all partition information, and the Windows setup process will automatically create two volumes for you. This gives you the desired configuration for BitLocker, but it comes at the expense of losing all data on your disk. And I recommend the wipe and load scenario really only when distributing new computers or when you do not care about losing data on your hard drive. Another option of getting a second volume on the disk, and this is really going to be the way that you're going to need to deploy it if you want to do what's called a PC refresh scenario, or upgrade or migrate from a Windows XP operating system, is to shrink the existing volume and create a new volume out of the leftover space. This operation leaves you your data intact and gives you the necessary configuration to enable BitLocker. You can script this operation using the diskpart shrink command, which is new in Windows Vista and Windows 7, but I find that it is much easier to use a new Windows 7 utility called the BitLocker Drive Encryption Hardware Configuration Tool. This tool automatically detects your hard drive configuration and creates a new volume for you. This new volume then becomes the active or boot to volume, and all of the associated boot application files are moved there. Furthermore, the BitLocker Drive Encryption Hardware Configuration Tool automatically hides this volume from the user in Windows Explorer, so the user really never is even aware of its existence. This technique is critical if you want to take advantage of the new hard link migration feature with the user state migration tool and use it in conjunction with automated BitLocker deployment. And I'll mention more on this hard link migration feature later. So let's get ready to set up your organization for BitLocker. There are a few things you need to take. Number one, all of your domain controllers need to be at least Server 2003 with Service Pack 1. If you have any domain controllers with Server 2003 RTM, upgrade them to Service Pack 1, or else users will be able to read any BitLocker recovery information for any computer on your network. The second thing you should do is to extend the schema if you do not have any Server 2008 domain controllers in your environment. This is because the schema extension introduces a few attributes that BitLocker uses to back up its recovery information to Active Directory. The next thing you should do is run this Microsoft-supported script to enable the computer account to back up its trusted platform module owner information. After that, you can take the new Windows 7 administrative templates that you find in C Windows Policy Definitions folder and copy them to the sysvol share on your domain controller. After that, you can open up the Group Policy Management console and configure your new BitLocker group policy settings. After you do that, at this point, you want to determine how you want to enforce BitLocker in your organization. And at a minimum, you should require that BitLocker recovery information must be backed up to Active Directory for operating system and data volumes. Another policy you should consider is to deny write access to any data drive unless it is encrypted. You can also mandate whether users rely on the TPM or are required to input a PIN or a USB startup key. So once you have your configurations in place, you should test to ensure that your computers can back up this information to Active Directory. And the next step is, as I mentioned earlier in my discussion about hard drive configuration requirements, you'll need to use the BitLocker drive encryption hardware configuration tool to automatically detect and create a new volume for storing BitLocker-related boot settings. This tool is really easy to use, and you can place it as a batch script in your answer file to ensure that it runs automatically during first user logon. When this command completes, you'll need to reboot your computer and enable BitLocker. And Microsoft provides a few tools for enabling BitLocker. You can do it through the GUI in the control panel, or you can use the manage-VDI command to enable BitLocker through the command line. The drawback to both of these methods is that it requires user interaction, because the user will have to accept a response to a change in the TPM settings in a pre-boot screen. So if you're doing mass-wide deployment of BitLocker, you'll need to get fancy with WMI. Fortunately, the folks at Microsoft provide a script that can do this for you. Although it is not officially supported, it does work like a charm. The script is called enableBitLocker.bbs, and it will take ownership of the TPM, send all recovery information to Active Directory, and enable BitLocker without any user input. So that's really it for BitLocker deployment. At this point, you should test the functionality and familiarize yourself with the various options for data recovery for BitLocker. And that's what I'll talk about next. So data recovery is important to know. You have to understand how this works before you even put BitLocker on any computer. So this is how it works. If you take a hard drive and try to boot your operating system from another computer, say if you swap your hard drive, or if you insert a WinPE environment, or say another environment that you would commonly use to reset an administrator's password on the computer, then you'll get something called the BitLocker recovery screen. Okay? This is a screen that will want you to input a 48-digit password, or you can provide a USB recovery key. So how do you get this 48-digit recovery password or this key? Well, you can create the USB recovery key from the control panel if you've done this ahead of time, or if you've configured BitLocker to back up recovery information to Active Directory, you can have your network administrator look at the properties of the computer account. All right, and there's a new BitLocker recovery tab if you install the BitLocker Active Directory Recovery Password Viewer that you can use, and you can get the user to read back the password ID that's presented in the BitLocker recovery screen, and the administrator can read back a recovery password that you can enter in to access your data. Okay? If you have a failing hard drive, or if you need to mount a BitLocker encrypted drive as a slave, such as if you have a USB to SATA connector and you need to access data from that, well, there's a command line tool that you can take to use the BitLocker recovery information to gain access to the BitLocker encrypted drive. So let's say your hardware starts failing in BitLocker. Your motherboard is toast, and you need to move your hard drive to a new computer. So how does this work? Well, if you're lucky enough to be in the operating system, you can go in the control panel and suspend BitLocker. Okay? You should always do this if you're moving a hard drive to a new system. So in the case that you can't boot into that operating system, then you can take the hard drive, place it in the new system, you'll get the BitLocker recovery screen, provide the BitLocker recovery password. That'll allow you temporary access to the system where you can then go in the control panel and suspend BitLocker from there. At this point, you can go into the TPM console and select the initialize TPM function. This process will back up TPM information to Active Directory. And at this juncture, you can go back into the control panel and resume BitLocker protection. Okay, so the next thing I want to talk about is the Windows recovery environment. This environment is akin to the Windows recovery console that was available in Windows XP. And what it is, it's essentially its own operating system that resides on your hard drive. And by default, Windows 7 integrates this Windows recovery environment into the F8 Safe Boot menu. So when you press F8 to boot to a computer, you'll get an option for repair your computer. And you can select this option to go to the Windows recovery environment. With the Windows recovery environment, if you have a problem such that your computer won't start, you can launch a startup repair. This is the environment where if you need to do a complete PC restore, you can do that as well. And you can do other tools from the command line. So if you've embedded the ImageX tool in the Windows recovery environment, you can actually capture an image of your operating system and store it to a network drive. So there's another tool that's really interesting called the Microsoft Diagnostics and Recovery tool. And this tool, you get it if you have purchased Windows 7 with software assurance. And what this tool is, it's essentially an extension to the Windows recovery environment that allows you to do more things. For instance, if you need to do an offline virus scan, you can boot to the MS Dart tool and launch the standalone system sweeper. Since the Dart tool is networkable, you can fetch the latest updates from the internet and do an offline virus scan. You can also uninstall hotfixes and recover any type of data that, say, if you formatted your drive. Well, you can use this tool to get some of that data back. So with Windows Vista, there was a big emphasis on placing the Windows recovery environment on its own volume. Okay, I still do that for my deployment with Windows 7, but for different reasons. In Windows Vista, if you have a Windows recovery environment that was stored on, let's see, a volume, if you had Windows recovery environment enabled at the same time with BitLocker, then you really couldn't perform a complete PC restore for a couple of reasons. Well, that's no longer the case in Windows 7. And Windows 7 deploys this recovery environment by default, and it resides on the operating system drive. Some folks have made a big deal about having the Windows recovery environment on its own volume. And really, my explanation for this is that the reason why you would want to do this is to give you a better probability of being able to boot to this environment so that you can recover your data in the event of a hardware failure. So here are a few ideas on how you can make it happen. It's just sort of to get you started. If you really want to take this further, you can read for more information in the search results that I've provided to you at the bottom of the slide. Okay, so as I mentioned earlier, user state migration is really one of my favorite topics in deployment, just because Windows 7 has this new feature that cuts migration times down significantly. So before I talk about that, I want to talk about the classic example of user state migration. And when IT departments would deploy new operating systems, the idea is to capture all of your data, push it to a network share, then install a new operating system on the drive. Once you're within that new operating system, you launch a tool, the user state migration, to look at the network share and bring back down all of your data. Okay? You still need to use this technique if you're going to be moving users' data from one computer to another. This is called a PC replacement scenario. But in the case that you are refreshing the same PC, say if you're upgrading a Windows XP or a Windows Vista operating computer to Windows 7, then you can use a new feature, or actually two new features in the user state migration tool that will allow you to accomplish a migration in very little time. You know, whereas a classic network migration scenario would take 30 minutes or an hour and a half or more because you had to push all of that data to a network drive, a hard link migration scenario takes place in constant time, and it normally completes in around 15 or 20 minutes. So this is a huge improvement in migration times, and the fact that you can use this in conjunction with BitLocker deployment makes it really useful for automating a whole ton of aspects of Windows 7 deployment. All right? One caveat with hard link migration is that you need to keep your existing partition information on the drive. So some of you, if you've deployed Windows XP, you may have a habit of running a network migration to push all of the user's files and settings to a network share and just wiping the drive completely, installing a new operating system, and then using the user state migration tool to bring back all of the data, files, and settings. Well, with hard link migration, you need to keep your existing partition information because it relies on the fact that you have this windows.old directory, as I demonstrated earlier. So it uses that. It will dig in this windows.old directory for your files and settings and just place links to the data of those files on your new Windows 7 operating system. Okay, so I'm approaching the end of the presentation here, but I want to show you a few more tips and tricks for automating Windows 7 deployment. There's Windows activation, and you can research a little bit more into this with the Volume Activation and Planning Guide. Microsoft Update is a feature that will not enable itself by default on Windows 7. So if you want to know how to do this, use these topics at the bottom of this slide to search for and understand how you can deploy the Microsoft Update feature in Windows 7. And there's also deploying the Arrow interface. If you've noticed, if you've deployed Windows 7 a few times already, Windows Arrow really won't enable itself by default, even if you've incorporated the right drivers. So if you want to learn about how you can do this, I've written a nice article on how you can deploy the Arrow interface in Windows 7. Basically, it resides on the fact that you have to inject all of your video drivers, and then you create a custom theme that you call during your answer file execution that will enable the Arrow interface as you log in for the first time. Okay, so here's a slide on questions. I want to actually show you all of this information that I just presented to you. I'll break apart from this presentation and just run a quick demo on it. And so I guess there's a law of demos. So let's keep our fingers crossed and hope that this law doesn't apply for this case. But right now, what you're looking at is a Windows 7 operating system that has just been installed. All right, automated domain join and user logon has taken place. Okay, and what you're looking at is the first logon screen. And the reason I say first is because I have my image configured so that it automatically logs you on twice. During the first time, the Windows imaging process will create the required partition requirements for the Windows recovery environment, which is what it's doing right here, along with the partition requirements for BitLocker drive encryption. After that completes, it will run the user state migration tool to look into the windows.old directory where the previously existing XP operating system is, and take all of your files and operating system settings and apply them to Windows 7. So as all of this takes place, feel free to submit your questions in the Q&A tab of the live meeting console, and I'll get to them as they come up. Some of these commands take a little while to run. So if you have any questions right now, I'll be happy to answer them for you.
That just came in. Can you explain the process of creating a corporate base image and the image deployment process?
Good question. That's actually a question that I like a lot, because one of my frustrations with deploying the Windows XP operating system is that you had to have a couple of images for different hardware types. Okay, you have these older style computers that have this processor type called a uniproc that supports a uniprocessor type, and then you had other computers that supported multiprocessor types, and you couldn't really keep an image that applied to both systems. Okay, so I'm going to break from answering that question and just show you that what's taking place here is it's created a new volume for the Windows recovery environment and enabled all the settings for it, and now it's doing the same for the BitLocker drive encryption. So back to the question, is that one of my favorite techniques in imaging has been with Windows Vista and Windows 7. Images are hardware agnostic now. So you can now do all of your imaging from a virtual machine, capture that image using your capturing tool, whether if it's MDT or Configuration Manager, or just simply WinPE with ImageX. All right? And you can capture your image and from a virtual environment and use offline command line tools to make your image more hardware specific. So I showed earlier how you can use the DISM command to inject a multitude of drivers into your image.
We have a couple more questions that just came in. One question is, will BitLocker conflict with any third-party encryption software on the PC?
That's a good question because there are a bunch of really good third-party encryption tools like TrueCrypt that do that for you. To be honest with you, I don't know. Yeah, I haven't tested BitLocker in conjunction with third-party disk encryption systems. I think it's an intriguing question because there can really be some useful tools because some of these third-party tools have really nice features. But if you find an answer to that question or if you want to investigate it, please let me know because and it definitely is on my to-do to try it out and see what comes of it. But I just don't know the answer to that question.
Another one just came in. Are WSUS services still compatible with Windows 7, or will there be an update to that as well?
Well, okay, so I'm not a WSUS guy. Keep in mind my role here. I'm a desktop support person, so I don't have too much knowledge with WSUS, although I think there's been an update to it recently, and you should check that out. I think it's WSUS, maybe SP2 for the new Windows 7. Now, don't count me on that, but just do a little Googling and find out. That's another question that I'm just not able to answer right now.
Someone just said WSUS works fine. We're using it with Windows 7.
Great.
Yeah.
Okay, good.
Thank you, Jeff. Another question that came in, with Windows 7, are we still able to utilize third-party image tools, for example, Ghost, or are we forced to use Microsoft's methods?
That's a good question, all right. So I'm going to break from that question and kind of point out what's happening here. User state migration. This is hard link migration taking place. Okay, if you have any familiarity with user state migration and the network imaging process, it would still be at 1% right now. Okay, now the user state migration has already gone through the capturing phase, and it's now in the load state or the application phase, where it's taken all of the files and settings from Windows.org and applying them to the new operating system. Okay, now, so back to the question, third-party imaging tools like Ghost, okay, you can still deploy Windows 7 with those tools, okay, but you may be limited in what you can do. For instance, you cannot use the DISM tool to inject drivers into the image, okay, because the DISM tool relies on the Windows imaging format or the .wim format. All right, so you want to consider, a move to a file-based imaging solution, which is what the Microsoft ImageX tool offers. There are a couple of reasons. The main thing is that you need to use it in conjunction with some of the other deployment tools. That if you're using Configuration Manager or Microsoft Deployment Toolkit or Windows Deployment Services, you'll need to use some of these new command line tools that rely on the new Windows imaging format.
We just have one more question. Does Active Directory keep a record of clients that are encrypted and their status?
Yes, good question. So that depends on whether you've implemented a group policy to state that back up all recovery information, all BitLocker recovery information to Active Directory. And that's, if you're doing BitLocker for your company, that is going to be your primary goal. You need to have this information backed up. And so what information does it back up? Well, for each computer account that you enable BitLocker, group policy, you should state that if you cannot talk to Active Directory, all right, then you should not be allowed to enable BitLocker. All right, that's a group policy setting. So it forces every computer on the domain that has BitLocker to store its BitLocker recovery information to Active Directory. Okay, you need to extend the schema for it because there are certain attributes in BitLocker that will store things like the recovery ID and the recovery password. So the answer to your question, yes. Every computer that has enabled BitLocker, if you implemented group policy, then it will back up that recovery information to Active Directory.
Right, we want to be respectful of people's time, so we are going to wrap it up here. We are going to be sending out a link to the recording. A lot of people were asking about if there would be a copy of the slide deck, so you will get a link to the recording and the slide deck. And you'll also be receiving an email with a link to a survey, a feedback survey. If you could fill that out, we're going to be raffling off Windows 7 license keys. So just look forward to those within the next 48 hours. And if you have any more questions, I have just a couple here. We will be in touch with you guys regarding any of those that came up. But thank you everyone so much for attending. And Greg, thank you very much for your time.
You're welcome. I've enjoyed it, and I hope you've all enjoyed it too and can take something away from this presentation. If you have any questions, let me show you my email address so that you can just send me an email if you have any deployment questions. I'll try to answer them as best as I can, but let's go back to the slide here. And just to give you a chance, if you want to copy down my email, there it is right there. All right, so once again, Tessa, thanks for your help, and everyone, thanks for joining. And you all have a good day.